Hi. Thank you. I apologize in advance because I didn't have much time to prepare this. I hope that it will be interesting for everyone. So, 5 years ago, I was working for a company called Adslot. Adslot as a marketplace for online advertisement. So from one side, you have the advertisers who want to buy online space for basically banners, and on the other side, you have publishers who want to sell the space. A very important feature of our platform was a page where the advertisers could list all the banner spaces that they want to purchase and book them for a certain period of time. So we had a date picker for each of the line items, and each date picker had a start and an end date. Also, our page had a main date picker on the top that encompassed all the period of the campaign. So basically, it included all the intervals of the line items. Now, until that point, the main paradigm for the development was object-oriented programming. In object-oriented programming, a date picker is going to be an object, and it is responsible of managing its own internal variables. So somewhere it will have saved that 20 June and that 30 September, and probably some other information. And the only way that the user code can access that is via methods. I assume that a date picker could have like a get state, set states, a callback when the data changes. Okay, but an important principle in object-oriented programming is that we want to isolate the internal implementation from the outside, okay, for compatibility reasons. Now, given this idea, it's quite easy to understand how the flow on the page could be. So if the main date picker is changed, if the user clicks on a new date, then we will have to update all the line items. So the main date picker will send a message, will tell every line item in our page, hey, you should update the dates that you have, okay? Likewise, if any of the line item date picker changes, it will have to communicate to the main date picker that the main date picker might need to update. Okay, so the flow is very, very easy. Of course, in reality, it had a lot of async calls to check the availability. It had to recalculate prices, which included discounts that were not trivial to calculate. But the idea of the flow is decently simple. Despite this, we always had a problem where we couldn't synchronize the main date picker with the line item date pickers. There would be always a case where the main date picker would show the wrong date or would fail to update the line item date pickers. We would fix this case and another case would pop up. You know, playing whack-a-mole, you tap one and it pops up somewhere else. Around the same time, Facebook was having exactly the same problem. They were not able to keep their icon that gives the user the number of unread messages synchronized with the actual number of unread messages and with the chat windows. And unlike us, Facebook had a lot of skill to throw at a problem. So if not even a lot of skill can help you to maintain your code, to make it consistent, so it's time to search for a different solution. Go. So the problem is that while the objects themselves are really good at keeping their internal state consistent, keeping the whole state of our page across objects consistent is difficult. Each object has to call other objects to tell them to update, and all the way around in the flow that we saw before. And this network of update calls, even in simple cases, becomes very quickly very unmaintainable. If you want to find a better solution for this problem, we have to start to think about the state of our web page. I'm sure that you heard the word state, and in this case, I tried to put a couple of definitions. So anything that can change in our application without changing your source code, the variables, the value of the variables inside your code. Or if we want a more web-centric definition, is everything that can change that you need to display a page. Okay, so let's see the problem that we have with the date pickers from the point of view of the state. Okay, a model for the state could be this one. Okay, so we have a start and an end date for the main date picker, and then we have a start and an end date for each of the line items. Okay, this is a radically different approach from how web development has been done in the previous years. Because what we've been taught is that we start with a view first, and then you implement the machinery behind the view. And this is the how. Instead, if we start to think about the state first, we want to think about the what. What information do we want to display to the user? Okay, so we're not even thinking about date pickers. We want to show to the user the start and then the end date of the campaign. We want to show the start and the end date of every item that the user is purchasing. Okay, so given this, what is our problem? The problem is that those two values end up being out of sync with all the other values. If there is a very simple solution for this, that is, we get rid of the part of the state that falls out of consistency. Okay, this is trivial to do, but it has some very interesting implications. So, do we have enough information to display our state? The answer is yes, because we can calculate the start value from the start values of all the line items. We just take the earliest. Same thing for the end value. We take the latest end value of the line items. This is quite an important break from object-oriented programming, because it means that we will have a date picker that does not contain its own state. And an object without state is a collection of functions. It's not really much of an object. So if we model our state as an array of the start and end date of the line items, it's also very useful to have an ID for each line item. This state cannot express the inconsistency that we had before. Like it's just not possible that this state will describe a condition where that main date picker is off sync with the line items. If we consider that our model is the vocabulary that we have to describe the state, the vocabulary that we have picked, this vocabulary does not have the word to say the main date picker is out of sync. Well, click. Okay. So when we render our date pickers, the start and the end date become only arguments to a function. Say we have a function that renders what we have. In React, this is the render function, and we're just passing arguments. the date picker code is not responsible anymore for managing those values. Okay. For the main date picker, we have a minimum and a maximum, as we described already. And we have a function, fail. Go back, not that much back. Sorry. Here we are. So let's think about this set line item and clamp all line items. So set line item will go and modify that list that we have. We'll take one line item and we'll change the start and the end date of that single line item. Clamp all line items will bring all the duration, the interval of every line item to the selected new interval. Okay. We probably want to unit test these functions. Okay, those are functions that modify the state. How do we write a unit test to ensure that those line items do not create an inconsistency with the main date picker? We cannot even write the test. Okay, unit tests are good, but the best unit test is the one that you don't have to write. Also, those those two functions can work straight on the state without having to call other objects. Okay, the operation is atomic. It happens in a single block of code. It's a single piece that does that, which helps even further maintain the consistency. This can be done only once virtual DOM rendering methods such as React became available. Because what is React doing? What is the virtual DOM doing? It is removing the responsibility of deciding when to render away from the object. Okay, so let's see another case of removing unwanted states. Now, date pickers are drop-downs, and every drop-down component can be showed open or closed. So the naive approach would be to create one variable for each one of our date pickers. So we have Boolean value for the main date picker that tells us if it is open or closed, and then one Boolean value for every one of our line item date pickers. This is obvious that this model can represent states that we don't want. In UI design, a well-accepted idea is that you want only one drop-down open at every given time. But this model, like if our Boolean values are all true, it means that all the drop-downs are going to be open. That's a state that we don't want. How do we change this model so that the only state that makes sense, the only state that it can describe as at maximum one open drop-down? And like the solution is trivial. Again, we just, rather than having a Boolean for each date picker, we have a reference to the date picker that we want open. This means that at most one date picker is going to be open. So let's go fully into the React world. We have our date picker component. We pass the start date and the end date, where we're calculating the minimum and the maximum. This is the main date picker. To decide whether the date picker is open or closed, it's the responsibility of the parent. The date picker just gets a property, an argument. Okay, the date picker does not decide whether it is open or closed. And this date picker is open when our reference variable equals to whatever ID we decided to assign to this particular date picker. Okay, so if the open date picker is main, then the main date picker is open. we have two functions to open a date picker and to close them. And that's something that I find really, like, it's very simple and it's really, really powerful. The very act of opening a date picker closes all the other date pickers. It is one and the same. You cannot open a date picker without closing all the others. This avoids a lot of bugs. This keeps your application, your interface solid and ultimately more pleasant, more easy to understand and to use. So we saw that there are advantages in bringing out the state from the object. In the React world, this is the component. So there are advantages in bringing out the state from the component to the world. If you are using a functional programming language like PureScript or ReasonML, Elm, Clojure with OM, you don't have choice. Like, you can't have objects, so all the state must be out in the wild. Most of the time, however, we are working with React, and React has a lot of stateful components. It has third-party libraries that give you stateful components. Most importantly, managing state out in the wild, like global state, in React requires to use Redux. And Redux is a pain in the ass because it has, like, it's great and all, it solves a lot of problems, but it has a lot of boilerplate. And probably you don't want to add boilerplate for a variable that only that component will ever use. So, in general, keep the state inside the component unless you can apply this technique and make impossible the states that you don't want, because we saw it, it's super useful. And also, if the parent needs to access, which means read or write, part of the state. The classical example is that you have a modal. The modal shouldn't know whether it is open or closed, visible or hidden. It shouldn't have state. It is the responsibility of the parent to tell the modal whether to display or not the modal. Even React complains about this. So again, we have to change radically the way we think about web development, because we have to think about the model first. We have to think about the information that we want to give to the user. We want to think about the information that we expect from the user. And if we model this correctly, this will make super easy, or at least a lot easier, to write our render methods, to write our update method, that our reducers, if we want to use Redux terminology. Okay. I think we saw this with Crocus, that when we changed the model, thinking about the various moving parts became a lot simpler. So to finish this, some languages, again, on the JavaScript world, we have ReasonML, we have PureScript, we have Elm. On the back end, we have OCaml, we have Haskell. These languages that offer ML types allow you to crank this technique up to 11. ML types allow you to describe even very weird states in a way that's super solid, that allows you to make impossible the overwhelming majority of states that you don't want. And also the compilers allow you, will help you with those states, will tell you if you're not managing all the states that you should do, which is fantastic, because the compiler will find the error for you before your user finds the error. If you want to have a look at how ML types can be used to make unwanted states impossible, there is a talk by Richard Feldman on YouTube titled Making Impossible States Impossible, which describes exactly this kind of stuff, but with Elm. I'm done. Thank you very much for your patience. I hope it was interesting. If you have any questions, I'm not leaving the office for the whole day.